So we can convert array references also in 3 address code. We can convert procedures like function definitions and some switch statements also we can convert into 3 address code. Let us go for arrays. So we can convert arrays into 3 address code. Now we have one dimensional array, two dimensional array. So let's go for 1D array. So let us take. So my screen is visible to all. So I am going to convert one dimensional array into 3 address code. So before going to converting one dimensional array into 3 address code, just I am going to discuss about 1D array. So let us take these are 5 elements. One dimensional array of 5 equals some elements. So these elements are stored in continuous memory location. So array index starts from 0 to 4. You know this one. And array element or every array element will be stored in some address. So if you consider the element 1 will be stored in 1000 address. So each element will takes 4 bytes of memory. That second element will be stored in 1004. And the same way the odd element will be stored in 1008 and so on. If array contains 5 elements, the last element will be stored in 1016 address. So this is my assumption. Base address is my assumption. So this is my base address. You can, if you want, you can take 100 or you can take 65,000 address, starting from 65,000. It depends on the compiler. So this is my base address. This is my index or lower bound. Lower bound starts from 0 value only. These are array elements. So the formula for one dimensional array is, so if you want to find, for example, a of 2, that is a of I am taking. If it is 2, then I am going to find a of 2. Generally, address of the element is a of I equals base address plus width into I minus lower bound. So if it is 2, then I will becomes 2. If it is 3, I want to find a of 3, then I value becomes 3. Lower bound is always 0. So for example, I want to find the array element at second position, index a of 2 element address. A of 2 equals base address starts from 1000. So this is base address. I am taking 1000 as base address. And let us assume that every element will stored with some 4 bytes. Every element will occupy memory as 4 bytes. So width will become 4. So a of 2, so that I am taking I value as 2. If it is 3, I am taking 3. So I am finding a of 2 element. So 2, lower bound is always 0. For formula wise, I am taking I minus LB. LB always it is 0 only lower bound value. So if you want, you can take simply width into I. Just base address plus width into I is enough. So 1000 plus 4 into 2, it is 8. So A of 2 element 58 is stored at address 1008 address. So the formula is base plus width into height. Let's take an example. If your program contains single dimensional array or one dimensional array, how to convert that one dimensional array into 3 address code. Let us assume this is the example. Into I into a of 10, I equals 1, while I less than 10, a of I equals something like 0, or you can take any value. I'm showing some value into a of I, and I equals I plus 1. I am closing while loop. So this is my program, simple program. It contains one dimensional array a of 10 address. I want to convert. I'm going to convert this program or this one dimensional array into 3 address code. So we cannot convert declaration parts into 3 address code. I'm skip this one. I'm starting from I equals 1. So I equals 1 already in 3 address code format. I'm going with I less than 10. So this is while condition. So for while we use go to statements. So if I less than 10, then go to some a of I equals 0, something that one. If this is true, then I'm going for fourth statement. If this condition is false, then I'm going with some other go to statement. For true, I'm taking this second line. For false, I'm taking third line. So a of I. So we need to convert this a of I value into 3 address code. A of I. Nothing but for converting a of I value, look at this one, this formula. So generally we use width base address plus width into some I minus LB. This is the formula for converting single dimensional array. So I am not taking considering this base address because it is depends on the compiler. Base address is varying compiler to compiler. So that I am omitting, I am not considering this base address. I am simply considering width into some index address. If it is 2, then I am taking 4 into 2. If it is 3, I am taking 4 into 3. So index A of I, lower bound is also not considering, it is always 0 only. Some width into index address. That is why I am taking T1 equals width is 4 bytes into I only. So if you want, you can take base address also 1000 plus or something B plus 4 into I also. So, but compiler is, it is base address is differ to compiler. So I'm not considering this base address. I'm taking only 4 into I. So here I. So T1 equals 4 into I. For this A of I, for this index I, I'm calculating 3 address code. For one dimensional array, if width is 4 bytes, then it will becomes 4 into I. If it occupies 2 bytes, then it will becomes 2 into I. So for this dimension, I am calculating 3 address code only for this dimension. So T1 is becomes 4 into I. Now A of T1 equals 0. A of T1 equals 0. Here T1 is nothing but 4 into I. And next line I equals I plus 1. It is already in 3 address code. No need to convert. Directly I am writing I equals I plus 1. And after this statement, this is while. So again it needs to check the condition, while condition. While I less than or equal to 10, I plus 1. If I becomes 2, then I again it needs to check 2 less than 10 condition. Again it needs to execute the A of I equals some 0 statements, and I plus until the condition fails, it needs to execute the while condition. For that time, seventh line should be go to of 2 only. If I less than 10, because it is while. If it is if condition, then simply I am going to stop this 3 address code, but it is while. So I am going to execute again second condition. That is why I am writing go to some label number 2. If this is true, then I am executing from 4, 5, 6, and 7. If it is false, then I am going to stop this program. That is 8. That is why I am putting go to of 8. So this way we can convert one dimensional array into 3 address code. The only thing is, if it occupies 4 bytes, I am taking 4 bytes. You also take 4 bytes only. Simply forget about dimension, and if it is 5, then you can write 4 into 5 directly 20. T1 equals 20 value, constant value, but it will give you some I index only. So 4 into I. If it takes 2 bytes, then you can take 2 into I. Simply in place of this I position, I am writing 4 into I. That 4 into I will be stored in T1, so that I am writing A of T1. This is what about one dimensional array. Moving to two-dimensional array, if your program contains 2D array, then how to convert 2D array into 3 address code? Let us take this example. A of 3 by 5, 3 rows and 5 columns. So 0th row, first row and second row with some elements with the 5 columns, 0 row, first row, second row, and column values. Let us take base address is same 1000 only. I'm taking base address. It is depends on the compiler. Let us assume that this element will store at 1000 address. This is completely my assumption. So base address is 1000. Again, width of every element is also 4 bytes. So, but when you are converting 3 address code for 2-dimensional array, we will find row major representation for the array and column major representation. If row major means 7, 5, 20, 19, 32, it is row 0. 10, 15, 2, 9, 20, it is row 1. 3, 1, 18, 11, 4 is row 2. This is row major representation. Column major representation means 7, 10, 3. This is column 0. And 5, 15, 1. 5, 15, 1. It is column 1 and third column 22, 18. So and 11, 9, 11. 19, sorry, 19, 9, 11 is column 3. So this is column measure representation. One second. So row measure and column measure representation. So for row measure, for formula for row measure is base address as it is plus width is as it is. The only thing is n into I minus LR minus LR plus J minus LC. Here LR means lower bound row 0 value. LC means lower bound column value. This is LC. LC is 0, LR is 0. There also we need to convert lower bound. Here also, if you want, you cannot convert. Consider, no need to consider these lower bound values. You can directly write the formula as some base address plus width into n into I plus j is enough. N into I plus j. A lower bound row value and lower bound column value is not required. You can directly write n into I. So for example, I want to find A of 2 by 3 element address. That is second row and column 3, 11th element address. So if you consider base address is 1000, if it occupies each element occupies 4 bytes, then it is 1000, 1004, 1008, 12, 16, 20, and 24, 28, 32, 36, 40, 44, 48, and 52. So 11th element will be stored in 1052 address. So 1052, the same way I'm going to find it formula wise. A of 2 by 3, base address is 1000. Here width is 4 bytes. Each element will occupy 4 bytes. And A of 3 by 4 array. So M value is 3, N value is 5. So N into, formula wise, N into some I value, Ij. This is A of Ij. So N into 2, I is 2 plus 3. I'm not writing minus 0, minus 0. LR value, LC value. So this will become 10 plus 3. So 4 into 13, it is 52. So I told you already 10,052. 1052 will store array element 11. It is 2 by 3. Second row, third, 11th element will store it 1052. The only thing is the formula for two-dimensional array. So 1052. So if we have A of Ij, you can directly write 4 into some index I plus some j. That way you can convert your two-dimensional array into 3 underscore. And coming to column measure representation, the only thing is here n into I, I'm taking just m into j. Here not no n. For column measure, we are for calculating column measure, base address plus width into I minus LR plus m into j. Here n into I. If you can remove this LR and LC as no problem. I plus m into j. Here n into I plus j. That is the only difference between row measure and column measure. Same table, can take same table A of 2 by 3 with the column measure address is different. Here row measure the address is 1052. If you consider column measure, it is 1000 column wise 4, 1004, 1008, 12, 16, 20, 24, 28, 32, 36, 40, 44. Column wise the address is 1044. So go with this example. Same with column measure A of 2 by 3, base address is 1000, width is 4 into 2, I is 2 plus, now M value, M is 3, previously N value 5, I am taking 5 into I, but now M into I, sorry M into J, 2 plus M value is 3 and J value also 3. So 4 into some 11, it becomes 1044. So column wise, the element 11 will be stored at 1044. Row wise, the element 11 will be stored at 1052. So let us take an example. Convert this example into 3 address code. Here into I, two-dimensional array. Size is 10 by 10. I equals 0. Same program. The only thing is here I am taking a of I, not ij. If you want to take ij also, a of I equals 5. I equals I plus 1. So I want to convert this C program into, if this program contains two-dimensional array, convert into 3 address code. First we need to calculate 3 address code for I. A of I. So I means 10 10. So 10 10 base address plus width is 4 into. So I'm finding for row major representation. If you want, you can take column major also, no problem. So here n value is 10 by 10. M and both are 10. So 10 into I value. I am going to find I, not any value. Simply, if it is ij, then I am going to find for ij, a of ij. So here both are I only. So 10 into I minus 0. Here also in j position also we have I only. So I am taking I only, I minus 0. Both are I. In between I minus 0, we have plus. Formula wise, it is n into I minus 0 plus j minus 0 actually. But my program contains a of I. Both are I. I position we have I, j position also we have I. So 10 into I minus 0 plus I minus 0. So base address plus 4 into 10i plus I again, 11i. If it is j, for example, a of ij, this will become 4 into 10i plus j. That is 44i plus 4j. 44i plus 4j is the final answer. Final expression we got from this expression. But here both are I and I. So I am getting 44i directly. So 3 address code for this I is 44i. I am not considering base address because it is depends on the compiler. Base address is always depends on the compiler. I am not taking B also. I'm removing this B. I'm simply writing 44i in T1 place. Look at the 3 address code. Starting from I equals 0 as it is. For true condition, for false condition. For true, I am going to execute T1 equals 44 into I. I am removing this base address. Base address will always depends on the compiler. So T1 equals 44i. So in place of I am going to write A of T1. A of T1 equals this 5. So I equals I plus 1 is already in 3 address code. So after executing these block of statements in while, again it needs to execute. It needs to check this while condition. For that I am writing go to of 2. After executing these statements, it needs to check again I less than 10 condition. So go to of 2. If this condition fails, directly I am going to enter line number 8. 8 line number is for stopping your program. So this way we can convert one-dimensional array and two-dimensional array into 3 address code. And the case statements, we have procedures. These are not there in your syllabus. We have only arrays. So 3 address code for arrays only. So for your reference, I am going with one example for switch statement. No big logics. Switch CH. Case 1 equals C equals A plus B, break. Case 2 C equals A minus B, break. If you have n number of cases, case 3 C equals A star B, then break. Case 4 C equals A by B, some break. If you have a program like this, we need to convert 3 address code. If CH choice, your choice equals 1, then I am going to execute. Now, directly you are not writing 3, you simply put some blank, go to of some blank. If switch 2, put some blank. That way, if you have number of cases or more, then you simply put go to some blank number. Later you will assign some numbers. So if it is 1, then I am going to perform C equals A plus B. That A plus B is there at 3, line number 3, then you write 3. For example, see if you have some more state cases like if CH equals 3, go to of something blank for multiplication, some division, we have some other case, then don't write 3, 5. After writing all case statements, then you fill go to blanks. So here only we have 2 cases. For that, third statement or third line will execute addition statement. C equals A plus B. It is already in 3 underscore format. No need to write. If you want, you can write T1 equals A plus B, then C equals T1. Or else you can directly write C equals A plus B. It is already in C plus B. After executing this one, you need to break. So for break means I am going to stop this statement. For break, For a break, I'm taking star, line number 8. So go to 8. And if CH equals 2, then go to 5. 5 is T1 equals A minus B, C equals. This way also you can write, or you can directly write C equals A minus B, no problem. After this, go to star. So this way we can convert if your program contains any switch statements. Then directly you can convert into 3 address code. And last one is procedure calls. So these two are not there in your syllabus. For your reference, I am talking about. I am discussing about switch statements and procedure calls. Your P is nothing but a function name. Here A1, A2, A3 are some actual parameters. These are declarations of parameters. Parameters A1, parameter A2, parameter A3, and parameter A. So this is function calling. Like if you call fact of some n or something like addition of some int a comma int b, that is call procedure name function name comma number of arguments you are passing. So let us take an example, then you will come to know. This is my program. Void main int x comma y swap of address of x comma address of y. Just swapping program. This program contains one function called like swap of address of x comma address of y and function definition as well. So this program I'm going to convert into 3 underscore. So first the compiler starts from main function. Main function is also need to call. We need to call main function. For that I'm calling main function first. Call main function, and then I'm declaring parameters, parameter ampersand x and parameter ampersand y. I'm calling a function swap here. Function call function name is swap. Call p. P is nothing but swap comma n. N is nothing but number of arguments. Number of arguments you are calling or you are passing. Here number of arguments are 2. So I am using call swap comma 2. So once we call, the function definition of swap will be executed. Here we have some statements like t equals star a equals star b equals t. Already these are in 3 address code. So I can directly write this into 3 address code and then finally stop the code. So this way we can convert procedure calls into 3 address code also. So this is what about intermediate code representation of arrays, case statements, and procedure calls. So if you have any queries, then you can post queries also.